Welcome to the deep dive. If you're a software engineer building services, you know the world is changing fast, especially with the rise of AI agents. These autonomous programs need to interact with the applications and systems we build every day.
Yeah, absolutely. And that interaction piece, well, that's where things get really interesting and, frankly, challenging. How do you make sure these agents can connect reliably, figure out what your service actually does, and then execute actions safely?
Exactly. Because the interfaces we've, traditionally used, things like REST APIs or GraphQL, they were designed with a specific user in mind, us, human developers writing code.
Right.
But AI agents, they operate differently, fundamentally so. And that creates some unique requirements that our standard APIs weren't really built to handle.
And that's really the heart of this deep dive. We're looking at the source material you share to explore this space, focusing on the differences between those, let's call them traditional API approaches, and a newer concept designed specifically for AI agents, the Model Context Protocol, or MCP.
Okay, so our goal today is to really unpack why this distinction matters more and more, especially for you, the SWE building these services. What does it actually mean to create interfaces that AI agents can not just consume, but truly understand and use effectively, especially in production?
Makes sense. So maybe let's start by digging into the problem that MCP is trying to solve. The source calls it the HTTP API problem.
Okay, the HTTP API problem sounds a bit dramatic, but I'm intrigued. What's the core issue there when an automated agent tries to use a typical API?
Well, just think about the sheer flexibility, or maybe a better term the source uses is combinatorial chaos that you find in traditional HTTP APIs.
Combinatorial chaos. Okay, break that down for me. What does that actually look like in practice when an AI agent is trying to, say, use an API?
It means that even for something simple, like identifying a resource or passing a parameter, there are just so many ways the data can be encoded and sent in a single request. It could be in the URL path, right? Like user settings 123.
Or maybe a query parameter, like .userid 123 an action update.
Exactly. Or maybe it's tucked away in a custom HTTP header.
Right.
And then you've got the request body. Could be JSON, could be XML, could be form data, could even be plain text. And each of those has its own structure.
Right.
So for one logical task the agent wants to perform, the inputs it needs might be scattered all over the place. And, the same piece of data might even look different depending on which endpoint you hit or which team built that part of the API.
And yeah, we have great tools like OpenAPI, Swagger. But the source makes a good point. They mostly describe the existing situation, right? They document the chaos, but they don't really enforce a standard way of doing things across different APIs or even within the same large API.
Precisely. OpenAPI is fantastic for a human developer to read the map, understand the variations. But for an automated agent, it's like trying to parse a guidebook, describing a city with inconsistent street signs and building numbers. It's not getting a protocol that guarantees a consistent structure for every single interaction. HTTP just wasn't designed for this kind of automated programmatic calling. It grew out of browser needs.
Okay, so the big challenge is this inherent lack of structure and consistency in traditional APIs. It makes it hard for an AI agent to reliably figure them out and use them without needing complex, potentially fragile logic just for interpretation. So how does MCP, the Model Context Protocol, approach this differently?
Well, MCP doesn't try to just add better documentation on top of inconsistent APIs. Instead, it defines a wire protocol. Think of it like defining the actual language and grammar rules that the agent and service must use to talk to each other. And those rules are strict.
So it's less about describing what is and more about prescribing this is the one way we communicate.
Exactly that. It uses something like JSON RPC 2.0 for the message format, making sure every action call looks consistent. Usually, a method name and a single JSON object holding all the parameters. No more hunting around. The source highlights a few key architectural bits that enable this.
Okay, tell me about those building blocks.
Right. So first you've got the transport. It can be streamable HTTP, sure, but crucially, it also supports STDO standard input-output right out of the box. That's pretty different, and we'll definitely circle back to why that matters.
Stravio, okay. Interesting. What else?
Then there's discovery.
Discovery for an AI agent. I'm guessing this isn't just reading a static spec file someone emailed over.
Exactly. This is a really fundamental difference. MCP has standard built-in commands that the agent can just call at runtime to ask the service, hey, what can you do? An agent calls tools list, and boom, it gets back a structured list of all the available actions and their input requirements. Or resources list for read-only data. The service tells the agent its capabilities dynamically, right then and there.
Huh. That sounds much more like how an intelligent agent would explore, you know? It doesn't need this preloaded, possibly out-of-date map. It can just ask, what tools do you have right now?
You got it. And finally, there are the primitives. The source talks about three main types. Tools, which are the actions the agent can make the service perform, like create calendar event or search repo.
Okay, actions. Makes sense.
Then resources, which are basically read-only data points like
Mm.
get user profile or list files. And prompts, which are like templates or structured ways the service can guide the agent if it needs specific output.
That structure seems pretty logical. Tools for doing, resources for knowing, prompts for guidance. And you mentioned JSON RPC 2.0 under the hood. For the SWEs listening, that's a lightweight protocol. It uses JSON for remote procedure calls. So that standardization helps enforce the consistency you were talking about.
That's right. It gives you that predictable structure right on the wire. Now, obviously, when you introduce a new protocol, especially for services, the first question many engineers will ask is, okay, but why not just extend OpenAPI? We already have that whole ecosystem.
Yeah, that's definitely the first thing that pops into my head. We've invested so much in OpenAPI, it's everywhere. Why reinvent the wheel? What does the source say about that?
It gives three pretty solid reasons. First one goes back to what we just discussed. OpenAPI describes, MCP prescribes. You can have the most detailed OpenAPI spec ever, but it doesn't force an endpoint to put the user ID in the header versus the path. It describes the inconsistency. For agents, you need that enforcement baked into the protocol itself to guarantee consistent patterns.
Okay, so describing the mess doesn't clean it up. Got it. Reason number 2.
Retrofitting just doesn't scale well. If you try to twist OpenAPI to really meet all these agent needs, runtime discovery, guaranteed single input location, proper bidirectional communication, standardized errors, you'd have to make such fundamental breaking changes. You'd basically end up creating a new incompatible protocol anyway.
Right. It wouldn't be OpenAPI as we know it anymore, and most existing APIs wouldn't support this new hypothetical version.
Exactly. Which leads straight into the third reason, the ecosystem problem. Even if OpenAPI did somehow evolve into this perfect agent protocol, you've still got millions of existing APIs out there documented the old way. They wouldn't magically update. You'd have this massive legacy landscape that's still not agent-friendly. MCP sort of bypasses that by starting fresh, specifically with AI principles in mind.
That makes a lot of sense. Sometimes it's just easier to build the right tool for the new job rather than trying to force fit an old one, especially given the scale we're talking about. Okay, so the source then really digs into 5 fundamental differences that make MCP more suitable for AI agents. Let's walk through those. First up, runtime discovery versus static specs.
Yeah, this one's huge for agents designed to be autonomous. With traditional APIs, if you add a new endpoint or maybe change the input schema for an existing one, the agent's understanding, which is usually based on that static OpenAPI file or maybe a generated client SDK, is suddenly wrong. It's outdated.
Right, and updating it means regenerating code, maybe redeploying the agent, manually changing configs.
Yeah.
It's a whole process, a real pain point actually in fast-moving development.
Exactly. With MCP, because you have those standard tools list and resources list calls, the agent just asks the service at runtime. It gets the latest, freshest list of what the service can do right now with the correct schemas. It can discover and adapt to changes on the fly without needing a code push every time the service evolves. That dynamic nature is just way better suited for agents that need to adapt.
That's a massive advantage for flexibility, definitely, and it decouples the agent's logic from the service's specific implementation details. Okay, second difference. Deterministic execution versus LLM-generated calls. This sounds critical, especially for production systems.
Oh, absolutely critical. This might be the single biggest advantage if you're the SWE exposing functionality to an agent. You see, with many current approaches, especially using function calling built on traditional APIs, the large language model itself is often tasked with, like, generating the raw HTTP request. It has to figure out the right URL, build the headers, format the JSON body, decide where each parameter goes.
And LLMs, well, they're amazing, but they're probabilistic. They can hallucinate details, right? They might get a parameter name slightly wrong, forget a required field, use the wrong date format.
Exactly. That introduces a huge amount of potential unreliability. Your agent's calls might fail in weird, unpredictable ways simply because the request itself was malformed by the LLM. Now, with MCP, the LLM's job is different and much safer. It doesn't write the request. It chooses the right tool name from the list the service provided via tools list. And then it provides the arguments as a single structured JSON object following the schema the service advertised for that tool.
Ah, I see. So the LLM picks the intent, the tool, and provides the data in the expected format. but the actual how running the tool is handled by regular, reliable code.
Exactly. The code you write, the implementation behind that specific MCP tool, is deterministic. It gets that structured JSON, validates it, performs the action, handles errors properly, does retries, logging all the robust stuff you'd normally do in backend code. The LLM just points and provides the structured input. The low-level, error-prone part of making the actual call is handled by predictable code. This makes the whole interaction vastly more reliable and, frankly, testable.
Okay, that's a really significant shift in responsibility. It definitely makes the idea of agents interacting with production systems feel, well, safer. Right, third difference, bidirectional communication.
Yeah, traditional APIs are mostly request response, right? The client asks, the server answers. There are ways to do server push, like WebSockets or server-sent events, but they often feel like add-ons, not really baked into the core API standards in a consistent way across the board.
And MCP handles this differently.
Yes, bidirectional communication is treated as a first-class feature in the MCP protocol design. This allows for much richer, more sort of back-and-forth interactions. The service isn't just passively waiting for requests. It can proactively send stuff back to the agent, or even ask the agent or the user behind the agent for things.
Like what kind of things?
Well, the source gives a couple of key examples. The service could ask the LLM for a completion like, I need more context to proceed. LLM, can you elaborate on this part? Or it can initiate elicitation, which is basically asking the human user directly for input via the agent. Hey, the agent needs your okay to delete this file. Please confirm using this prompt. It can also just push status updates or notifications. This integrated back and forth supports way more complex interactive workflows.
That feels pretty essential for any agent doing tasks that might need, user confirmation or clarification midstream. Okay, fourth difference.
Single request human tasks. Think about how we design REST APIs. Often, a single thing a user wants to do, like creating a calendar event, gets broken down into multiple API calls. You might need one call to check availability, another POT to create the event resource, maybe another call to add attendees, maybe yet another to handle notifications.
Right, and the agent has to manage that whole sequence, understand the dependencies, handle errors at each step. Adds a lot of complexity to the agent's logic.
Precisely. MCP tools, however, are often designed to map more directly to a complete atomic human task. So if a single MCP tool calls a calendar.create event would take all the necessary info time, attendees, description, in one structured input object. The deterministic code behind that one tool then handles orchestrating all the underlying steps, maybe calling internal APIs or whatnot.
So the complexity of that multi-step workflow gets hidden, encapsulated inside the tool implementation on the server. The agent doesn't have to worry about it.
Correct. The agent just says, goal, create event. Here's the info. The MCP tool takes care of the rest reliably. It really simplifies the agent's view of the world.
Okay, that makes sense. And the final difference, local first by design. This one really stood out to me as different from typical web stuff.
It really is. Web APIs, by definition, run over HTTP, need a network connection, need a server, listening on a port, you worry about cores, authentication headers, all that jazz. MCP, while it can run over HTTP, was designed with Saccadio's standard input-output as a primary first-class transport mechanism.
Meaning an MCP service can just run as a local process, talking over stenced out, no web server needed for local stuff.
Exactly. And the implication there is pretty powerful. When an MCP service runs locally via Stentio, it usually just inherits the permissions of whatever process started it. So you can expose tools that do inherently local things, reading or writing files on the user's machine, running shell commands, interacting with other local apps or system utilities, all through the same structured MCP tool interface.
Wow, okay. That completely changes the game in terms of what kinds of capabilities you can give an agent in a standardized way. It's not just about talking to remote web services anymore.
Right. You could obviously run a local HTTP server to do some of this, but the fact that MCP prioritized Stdio from the start really shifts the mindset. It makes the user's own computer a first-class environment that agents can interact with through a consistent protocol.
So thinking about all these differences together, the runtime discovery, the deterministic execution, the back-and-forth communication, the task-based tools, this local access, it feels like this level of standardization could really benefit the AI models themselves down the line. The source mentions a training advantage.
It does, yeah. Think about how models learn to use software now. They have to ingest natural language descriptions, maybe browse API docs, try to figure out patterns across literally thousands, maybe millions of totally unique, often inconsistent APIs. It's an incredibly messy, fragmented learning task.
Sounds like trying to learn 1,000 different, slightly broken dialects of the same language all at once.
That's a good analogy. With MCP, because the interaction pattern is always the same tools list shows you what's available, ToolScald takes structured JSON, errors look. Consistent models could, in theory, be trained on one single consistent way to use any MCP service.
So even with today's function calling models, just the fact that MCP is uniform across different services gives an immediate practical benefit. The model doesn't have to relearn how to call something every time.
Absolutely. The fundamental mechanics are always the same.
Oh, yeah.
It knows how to discover, it knows how to call, it knows how to interpret the basic response structure. This standardization could make future models way more efficient and effective at actually using the software tools we build.
That paints a really interesting picture for where agent interaction could go. But let's be realistic, right? We're not going to just rip out every existing REST API and replace it with MCP tomorrow. How do these two worlds, the huge existing API landscape and this new protocol, actually coexist?
Yeah, and the source makes a really crucial point here, especially for SWEs thinking about architecture. They're layers, not competitors. The practical path forward, at least for now, involves using both.
Meaning an MCP server can act as sort of an adapter, sitting in front of existing APIs?
Precisely. You can have an AI agent talking MCP to an MCP server. That server then acts as a translator, taking the structured MCP call and figuring out how to make the necessary sequence of calls to your existing REST or GraphQL APIs behind the scenes to fulfill the request.
So the flow is like agent talks MCP server, adapter talks traditional API, your actual service logic.
Exactly that flow. This lets you keep your existing, probably well-tested APIs that maybe human devs or other clients use, while still giving AI agents that cleaner, more reliable MCP interface designed for them. You get the AI-friendly benefits without having to rewrite your entire backend.
Okay, that sounds like a much more pragmatic approach for integrating agents into the systems we already have. The source uses this example about finding security PRs and making a report. That really seemed to highlight the difference this layering makes for the agent itself.
It really does. Imagine an agent trying to do that task using just, say, the GitHub REST API with OpenAPI docs. The agent's core intelligence, its LLM brain, would have to spend a ton of effort just figuring out the API mechanics. Which endpoint lists PRs? How do I filter by security? How does pagination work? Oh, now I need to fetch details for each PR. How do I with the comments? What about rate limits?
Yeah, the agent's getting bogged down in the low-level details of how to talk to the API rather than the actual task.
Exactly. It's focused on API integration. Now contrast that with an MCP approach.
Right.
Maybe there's an MCP server acting as an adapter. The agent's job becomes much simpler. It just needs to figure out, I need a tool to search GitHub issues and PRs. It finds a tool like github.searchissues and via tools list and calls it with a single, simple JSON input like .query security type pre.
And all that complexity, hitting the right endpoints, handling the pagination, dealing with rate limits, maybe even fetching related data, that's all hidden inside the deterministic code running behind that single GitHub search issues and priors MCP tool on the server side.
Yes. The agent just states its need clearly and provides the parameters. The reliable code handles the messy parts. The agent then gets back structured results, again via the consistent MCP protocol. Its focus totally shifts to the actual goal, analyzing those results and writing the report.
That's a night and day difference. The agent is freed up to do the high-level reasoning and synthesis, which is what it's good at, instead of wrestling with API specifics.
Yeah, that example really drives home the benefit of MCP's prescriptive, task-focused nature for AI agents.
Okay, so let's try to synthesize this. What's the core takeaway from the source material when comparing MCP and traditional APIs, specifically through the lens of AI agents?
Well, the bottom line seems to be, traditional APIs grew up serving human developers and web browsers. That led to flexibility and variation, which is great for humans, but creates real challenges for reliable automation by agents. MCP, on the other hand, was designed from the ground up for agents, prioritizing things like standardization, runtime discovery, deterministic execution, and that richer bidirectional communication.
Right, and those structural advantages like making local actions possible, ensuring pool calls are reliable because they run deterministic code, enabling the server to initiate communication, these are pretty fundamental differences that are hard or maybe impossible to just retrofit onto standard API architectures.
Exactly. So for you as an SWE, the practical path forward is likely recognizing this difference. You'll probably keep your existing APIs for humans and traditional clients, but look at adding an MCP layer, as the specific dedicated front door for AI agents to ensure smoother, more reliable integration.
It definitely makes you reconsider how we design services moving forward. As AI agents become, more common and capable users of our systems, the interfaces we build probably need to evolve beyond just being well documented for other humans.
And that really leads to a key question for anyone building software right now.
Which brings us to our provocative thought for you, the listener, the software engineer designing these future systems. Knowing the unique requirements of AI agents and seeing protocols like MCP emerge specifically for them, how might this change how you approach designing new services? Or even how you think about evolving the ones you already maintain?
Yeah, how does thinking about potentially needing a dual interface, one optimized for human devs, another for agents, affect your architecture choices? And maybe even how will the way we build APIs for humans eventually be influenced by these needs of our new AI agent users?
It's definitely an evolving space, and thinking about these different interaction models now, it is pretty crucial. Thanks for joining us for this deep dive.